you ever tried eating a meal without salt? That bland, empty taste can linger in your memory even longer than a delicious feast. Salt, often dismissed as a humble seasoning on the dining table, is in fact a strategic resource that has helped shape trade, industry, and even human history. It's also the most widely used ingredient in kitchens around the world, preserving food while enhancing the flavor of meat and fish. But where does salt come from, and how is it made? To find out, we visited one of the largest salt fields on the planet, where more than 100 million tons of sea salt are harvested every year. Here, the journey begins across dazzling white salt flats stretching to the horizon, where nature and technology work together to transform seawater into the sparkling salt crystals we use every day. This is the largest and most sustainable salt field in the world, spanning 200,000 acres, home to the planet's most important salt exporter. Here, about 40,000 tons of salt are produced every day, with a purity level reaching 99%. What's fascinating is that even though the world has changed dramatically over hundreds of years, the way humans make salt has remained almost the same at its core. From shimmering salt flats under the sun to pristine white crystals, the basic process hasn't changed. Seawater is channeled into evaporation ponds, left for the sun and wind to slowly evaporate, leaving behind solid crystallized layers. The only difference lies in the scale and technology involved, from small salt pans harvested by just a few workers to today's sprawling fields stretching across thousands of hectares, combined with modern machinery for collection and refining. In other words, salt is still created through nature's patience. Only now, human hands have found a way to make the process faster and on a much larger scale. Every December, when the weather turns dry, sunny, and with little rain, the ideal conditions for salt crystallization, the coastal salt fields begin a new production season. Farmers start by restoring the entire salt field system to prepare for the upcoming harvest. After months under the sun, the salt flats dry and crack into large patches. At this point, farmers use heavy rollers to break apart the hardened soil, soak it with water to soften it, and then level the surface again. This step is crucial because the crystallization process depends entirely on how seawater is spread across the evaporation ponds. If the ground isn't even, water will pool in low spots, causing the salt to crystallize too thick, while other areas dry too quickly, preventing crystals from forming at all. A standard salt field is usually divided into three main sections: the brine settling pond, the brine concentration pond, and the salt crystallization pond. First are the settling ponds, where seawater is cleaned before entering the system. Next come the concentration ponds, where the salt content is gradually increased. And finally, on the dazzling crystallization beds under the sun and sea breeze, fresh salt crystals slowly begin to form. Once the salt fields are ready, seawater is channeled directly from offshore into the settling ponds through large pipelines. Each pond can hold up to 180,000 gallons, and the intake must coincide with high tide to ensure stable salinity. The water is then left to rest for 1 to 3 days, allowing sand, algae, plankton, and other impurities to settle at the bottom. At this stage, farmers use specialized instruments to measure salinity, determining whether the water has reached the saturation point needed to begin salt crystallization. When the brine meets the required level, it is directed through narrow channels into evaporation ponds. Under sunlight and sea breezes, evaporation occurs continuously, raising salinity from the initial 3 to 5% to around 20 to 25%. This step can take several days or even over a week, depending on weather and humidity. Once salinity reaches about 24 to 26%, the brine is moved to crystallization beds, flat, shallow ponds that hold just 1.2 to 2.0 inches of water. This is the ideal depth for sun and wind to act evenly, helping water evaporate consistently. After 2 to 5 days, sodium chloride crystals begin to appear on the bottom, gradually forming a bright white layer across the pond. Timing is everything. Harvesting too early stirs the liquid, accelerating evaporation and causing excess water loss. Leave it too long, and the salt flakes fuse together, making them harder to separate. Finding the perfect moment comes only with experience. Interestingly, instead of forming as loose grains, the initial salt crystals bond into thin sheets that can be broken apart into large slabs. Once the crystals have built up into a thick layer covering the pond, farmers begin harvesting. Surprisingly, very little effort is required. Brine acts as a lubricant, allowing the salt to detach easily. Large wooden or metal rakes are used to gather the salt into piles, draining off the remaining seawater. These gleaming white mounds are then loaded onto carts or specialized vehicles and transported to collection points along the pond's edge. On large-scale salt fields, mechanical harvesting is the most efficient option, boosting productivity while greatly reducing manual labor. Today, the most common equipment is the self-propelled salt harvester. Equipped with a front-mounted cutting blade and an angled conveyor system, these machines can complete the entire collection process in a single pass. Unlike older models that were used only for transporting salt, modern harvesters integrate 3 functions: raking, collecting, and storing. As the machine moves forward, the front blade pushes crystallized salt toward the center. There, a screw conveyor lifts the salt and transfers it directly into a rear storage tank, capable of holding several tons. This dramatically shortens harvesting time while improving transport efficiency, meeting the demands of large-scale industrial salt production. However, machine harvesting comes with a drawback. The collected salt often contains natural impurities such as sand, mud, and even broken seashells. To address this, trucks loaded with salt are taken directly to a washing station. Here, the salt is dumped into an underground intake system, then carried by conveyors into washing tanks. Inside, rotating screw agitators constantly churn the salt, flushing away impurities. Once cleaned, the salt continues along a conveyor to a massive machine called a stacker. This device steadily releases the salt, piling it into towering white mountains in the storage yard. Thanks to this system, the salt is neatly consolidated into high stacks, making it easier to store, maintain quality control, and prepare for refining or export. When an order comes in, the harvested and processed salt is transported to the ports. There, massive gleaming blocks of salt are loaded onto giant cargo ships, ready for their journey across the seas. Each vessel can carry between 150,000 and 200,000 tons of salt in a single trip. Once the ships arrive fully loaded at their destination, the unloading process begins. Enormous cranes equipped with specialized clamshell buckets lift batch after batch of salt from deep inside the ship's hold, depositing it into giant hoppers. From there, the salt flows onto an extended conveyor system, traveling across multiple sections before reaching the vast warehouses at the port. These facilities serve as temporary storage and staging areas, where the salt is held before being sorted and processed. At first glance, those bright white salt blocks may look clean, but in reality, they still contain many impurities and cannot be used directly as table salt. To become the pure product found in kitchens, the raw salt must go through several additional processing steps. First, the salt is transferred into multi-stage washing tanks, where fresh water removes fine sand, mud, microorganisms, and dissolved impurities. Vibrating screens and centrifuges are added to separate both heavy and light contaminants without dissolving the salt crystals. Next, the saturated brine solution is passed through a multi-stage filtration system to eliminate calcium, magnesium, heavy metals, and any remaining insoluble residues. Depending on requirements, this step may involve settling tanks, pressure filters, sand and activated carbon filters, or the addition of chemical precipitants such as soda ash, sodium bicarbonate, or lime to remove excess minerals. Once purified, the brine is sent into vacuum crystallizers or multi-effect evaporators. Here, temperature and pressure are carefully controlled so that water evaporates gradually, allowing the salt to recrystallize into fine, uniform grains. Afterward, the salt moves into hot air drying chambers, typically fluidized bed dryers or continuous conveyor dryers. The temperature is precisely regulated to completely remove moisture without causing clumping or altering the salt's quality. Finally, as it exits the dryer, the salt is cooled with air to prevent it from reabsorbing humidity. Depending on its intended use, once dried, the salt is fed into grinding machines to produce different grain sizes, from ultra-fine powdered salt to standard table salt crystals, to coarse salt for industrial processing and manufacturing. Crushing systems combined with vibrating screens, or even air classification, separate the crystals by size, ensuring the final product is uniform and consistent in quality. Afterward, workers perform manual inspections to remove any remaining impurities. Samples are also taken to measure grain size and compare against established technical standards. For table salt, an essential step is the addition of potassium iodide to help prevent goiter. Anti-caking agents such as magnesium carbonate, calcium silicate, or calcium phosphate are also added, ensuring the salt remains free-flowing and does not clump during storage. Finally, the finished salt is packaged in bags of various sizes and shipped to restaurants, supermarkets, and millions of kitchens around the world.